Assalamualaikum warahmatullahi wabarakatuh. So, kita akan lihat integration for today. Okay, the lesson on area of shaded region. Okay, for area of a region. Okay, the first is to see or recognize the area of a region between the curve and the x-axis. Now let's say we have a curve of y equal to fx, okay, and we are going to find the area of the shaded region, okay, between x equal to a to x equal to b, right, and the region is between the curve and the x-axis. Okay, so using integration we can find the area, okay, where we need to find the integral from a to b of y dx. So y is the function of x, a and b are the limits, okay, because the shaded region starts from a, ends to b. Okay, now if we have a shaded region between the curve and the x-axis, okay, if the shaded region is above the x-axis, the value of the integral will be positive. But if the shaded region between the curve and the x-axis stated below the x-axis, so the value of the integral will be negative. Okay, so if we want to find the area, then we have to modulus or find the absolute value of the integral. Okay, second we'll see at the area of region between the curve and the y-axis. So let's say we have a curve of x equal to gy. Okay, we need to find the area of the shaded region between the curve and the y-axis, okay, where the shaded region is from y equal to a to y equal to b. So using integral, area can be found by finding the integral from a to b of x dy. So now x will be the function of gy. Okay, so x will be the subject with in terms of y. Okay, we look at this situation. So if the region between the curve and the y-axis is on the right of the y-axis, the integral value is positive. Okay, and if the region is to the left of the y-axis, so the integral value is negative. Okay, let's look at a few examples. So for 1a, we need to find the area for the shaded region. So looking at this shaded region, the shaded region is between the curve y and the x-axis. Okay, and the shaded region starts from 0 from the x-axis and ends at 3 on the x-axis. Okay, so the area can be found by finding the integral from 0 to 3. Okay, the limits comes from the x-axis, so it will be a function of y in terms of x. So we have 3x minus x squared plus 2 dx, okay, with respect to x. Now let's integrate term by term. So we have 3x as 3x squared over 2 minus x cubed over 3 plus 2x with limits 0 to 3. Next, we substitute the upper limit 3 into the function minus the substitution of the lower limit 0. So let's calculate. So we can find the area of the shaded region as 21 1 over 2 units square. Okay, next we need to find the area of the shaded region. Okay, now the shaded region is between the curve y equal to half x square to the x-axis. Okay, and the shaded region starts from -3 from the x-axis, ends at x equal to 2. So we can find the area of the shaded region, okay, by integrate or find the integral from -3 to 2, okay, 1 over 2 x square dx. Okay, so make sure when limits come from the x-axis, okay, you should have a function of x and then dx with respect to x. Okay, so let's integrate. Okay, the integration will be x cubed over 6 with limits -3 to 2, and then substitute the upper limits minus substitution of the lower limit, and let's calculate the area. So the area is 5 over 6 units square. Okay, now we need to find the area of shaded region. Now the shaded region is between the curve and the y-axis. Okay, so now the shaded region is between the curve x equal to y square plus y minus 6 and the y-axis. Alright, so to find the area, okay, is to find the integral from -2 to 1, okay, because the shaded region starts from -2 from the y-axis to 1, okay, of the y-axis. So the limits -2 to 1, okay, function x, which is y square plus y minus 6 with respect to y, dy. Okay, we need to have the absolute sign because now the region is on the left of the y-axis. Okay, so the integral value will be negative. Therefore, the area, okay, will be the modulus of your integral. Okay, now let's integrate. So we have y cubed over 3 plus y square over 2 minus 6y with limits -2 and 1. And then we substitute the upper limit, okay, with 1, y1, minus substitution of the lower limit, -2. And let's calculate the area. So the area is 16.5 units square. Okay, next. Now we need to find the area of the shaded region. Okay, so now the shaded region is, there are two shaded regions. One is below the x-axis and another is above the x-axis. And the shaded regions are between the curve and the x-axis. So we need to identify the limits. Now the shaded region starts from -2 to 0 for the region below the x-axis. Now remember, when the region below the x-axis, between the curve and the x-axis, we can define that the integral value is negative. Okay, so we need to find the area, means we need to absolute the area, the integral. Okay, next, the second region starts from 0. Okay, now the x-intercept for the next value of the x-intercept will be 4. Okay, so we have 4 as the upper limit. Okay, so the area will be the integral from -2 to 0, okay, of function y dx. Okay, this first region, okay, should be in the absolute sign, and then we need to plus with the second region, okay, the limits from 0 to 4, okay, of function y dx. So let's integrate. So the integration will be x to the power of 4 over 4, okay, negative x to the power of 4 over 4, plus x cubed over 3 plus 6x squared, okay, with limits -2 to 0, plus, okay, the second region will be, okay, from 0 to 4. Okay, now let's substitute the upper limit, okay, minus with substitution of the lower limit for both regions, and then we calculate. So the area will be 0 minus 17 1 over 3 plus, okay, the second is 53 1 over 3 minus 0. So the area for both regions will be 72 over 3 units square. Okay, next, we need to find the area of the shaded region. So now the shaded region is between the straight line and the curve. Okay, so it starts from 0, and we need to find the end points, okay, of the shaded region. So means that we need to find the intersection point between both graphs. Okay, so by solving simultaneous equation, substitute -2x plus 5, okay, into y equal to x squared minus 4x plus 5. Okay, now we have quadratic equation, so we write in general form, x squared minus 2x equal to 0. Next, to solve the equation by factorization, so we will have x0 and x2. Okay, so let's find the values of y. So when x0, y is 5, and when x2, y is 1. Okay, now from the graph, okay, we can find the area of shaded region by finding the area of the trapezium, okay, and then we have to minus with area of area between the curve and the x-axis. Okay, so theoretically we can find the area of shaded region by finding the area of the trapezium, okay, below between the straight line and the x-axis, okay, minus with the area between the curve and the x-axis. Okay, so area of trapezium will be half times 1 plus 5, okay, the additions of two parallel lines times the height 2, and then we have to minus with the integral the area between the curve and the x-axis, so limits 0 to 2 of x squared minus 4x plus 5 dx. Okay, let's calculate. So the area of trapezium is 6 minus, okay, we have to find the integral x cubed over 3 minus 2x squared plus 5x with limits 0 to 2. Next, we substitute the upper limit 2 and minus with the substitution of lower limit 0. Okay, therefore the area is 1 over 3 units square. Okay, next we need to find the area of the shaded region. So now look at the graph. Okay, we have two graphs. One is y squared equal to 5x. Another is 2y equal to negative x. Okay, so the region is between the straight line to the y-axis, or the triangle. Okay, the shape will be triangle. And then we have to minus with the area between the curve to the y-axis. Okay, we choose the curve to the y-axis. Okay, because if not, you can find the curve to the x, but then you have to minus with the triangle. So either one. Okay, by looking at the function, okay, it is much easier if we find the region between the curve to the y-axis. Okay, now first thing is to find the intersection points between both graphs. So using simultaneous equation, we substitute y into the nonlinear equation. Next, we solve the equation by factorization. So here we will have two intersection points. One is when x0 and y0. Another point is when x20 and y negative 10. Okay, the area of shaded region will be the area of triangle to the y-axis, okay, minus the area between the curve to the y-axis. Okay, area of triangle will be half times the base 20 times the height 10. Okay, this is the area of triangle. And then minus the integral from negative 10 to 0, okay, of function y squared over 5. Okay, it should be dy here. So we integrate with respect to y. 100 minus y cubed over 15 from negative 10 to 0. I'm sorry. Dx should be changed to dy. Okay, now let's substitute the upper limit minus with the substitution of lower limit. Okay, and let's find out the area. So the area of the shaded region will be 33 1/3 units square. Okay, next. Okay, we need to find if the curve y equal to negative x cubed minus x squared intersects the curve y equal to negative x minus x squared at points negative 1, 0, 0, 0, and 1, negative 2. So now we need to find the area between the two curves. Okay. So let's sketch the first curve. We have y equal to negative x minus x squared. Alright. And then we have the second curve, the cubic curve. Okay, that is negative x cubed minus x squared. Alright. So the shaded region between the two curves, okay, will be the colored region. Okay. So those are the points of intersections. Okay, now we need to find the area of the colored regions, right, between the two curves. So it involves 3 areas. Okay, so first area is between the curve y equal to negative x minus s squared to the x-axis. Okay, the second region will be between the curve, the cubic curve to the x-axis, and the third region is between both graphs. Okay, so we have to find the area between the quadratic graph, and then we have to minus with the area between the cubic graph to the x-axis. Okay, that is the theory. So area of shaded region will be area 1 plus area 2 plus area 3. Okay, area 1 will be the area starts from negative 1 to 0 of negative x minus s squared dx. Area 2 is below the x-axis, so we have to write down the integral in absolute sign bracket. So starts from negative 1 to 0 of function cubic negative x cubed minus s squared dx. And then for the third region, area 3, so we have to find the area from 0 to 1 of the quadratic graph negative x minus s squared dx to the x-axis, and then we have to minus to the area between the curve, the cubic curve, to the x-axis. Okay, with the same limits from 0 to 1. Okay, with function negative x cubed minus s squared dx. Okay, let's find the integrations. So we have negative x squared over 2 minus x cubed over 3 with limits negative 1 to 0, and we have x to the power negative x to the power of 4 over 4 minus x cubed over 3 with limits negative 1 to 0. Okay, so we have 4 regions here. So let's substitute the upper limit and then minus with the substitution of the lower limit. Okay, finally we have the area as 5 over 6. Okay, next we were given that the curves y equal to x squared minus 4x and y equal to 2x minus x squared intersect at 2 points. Okay, now we need to find the area of the region between the two curves. Okay, let's sketch our graphs. So we have quadratic y equal to 2x minus x squared, and we have another curve quadratic y equal to x squared minus 4x. Okay, so we have two graphs. Now the area between the two curves, okay, so first we need to find the intersection between both graphs. So solving simultaneous. Okay, we have 2x minus x squared equal to x squared minus 4x. Change to general form. 2x squared minus 6x is 0. Then we factorize to solve the equation. So the value of x are 0 and 3. Okay, next we find the values of y. So the intersection points will be 0, 0 and 3 negative. 3. Okay, now the region between the two curves, okay, will be the colored region. So it involves two areas. One is the area between the curve y equal to 2x minus x squared to the x-axis. Another will be, okay, area 2, where area 2 will be the area from 0 to 3, okay, of the curve x squared minus 4x, okay, and then we have to minus to the region between 2 to 3, okay, of 2x minus x squared dx, okay, because area 2 is between the blue curve to the x-axis. We have to minus with the area between the curve y equal to 2x minus x squared to the x-axis. Okay, let's integrate. Okay, so we have to find x square minus x cubed over 3, the integral values function with limit 0 to 2 plus x cubed over 3 minus 2x squared with limit 0 3 and minus 2x squared minus x cubed over 3 with limits 2 to 3. Okay, let's calculate. Substitute upper limits minus substitution of the lower limits. Okay, so we have found the area, okay, of the shaded region as 9 units square. Alright, so that's all for today. Thank you.